All right, this is 3-6, homework, parallel and perpendicular lines. All right, so here at the top we have a review of what parallel lines are. It says two lines are parallel if they lie in the same plane and never intersect. They're going to look like railroad tracks, basically. All right. Now the same plane, that doesn't really, that's something that's a little beyond what we're covering right now, but it basically, this would be considered a two-dimensional plane, X and Y. Later on in other math classes, you'll deal with three-dimensional planes, like X, Y, and Z would be coming outwards, okay? But the main thing you need to understand about parallel lines right now is they have the same slope, but a different y-intercept, okay? So an example might be y equals 2x plus 3, and then y equals 2x plus 5. They have the exact same slope, but different y-intercepts. Perpendicular lines, on the other hand, they are not railroad tracks. Perpendicular lines are lines that intersect at all right angles. Okay, like if I were to cross these, it'd be a right angle on every corner. Okay, so kind of like grid lines. Perpendicular lines have slopes that are negative reciprocals of each other, and that's a mouthful right here, negative reciprocals. What that means is, if I had this first equation, y equals 2x plus 3, I'll use again. This slope is 2. But what I have to do is, I have to flip that upside down, and I have to change the sign. So changing the sign makes it opposite of whatever it was. And reciprocal means you flip it upside down. Now, how do you flip a number upside down if there's not a fraction? Well, 2 is the same thing as 2 over 1. So if you remember that, and then you flip it upside down, a line with a negative reciprocal slope would be turned to 1/2, and I would change it from positive to negative. It would be negative 1/2 x. And I can use the same b value if I want. It doesn't really matter. Okay? What I'm going to do real quick is I'm going to graph that in the calculator so you can take a look at it. So I'm going to go ahead and go to my graph screen, and I'm going to clear out my old stuff, and I'm going to actually graph y equals 2x plus 3. I'll try to put it where you can see it without glare. Okay, so y equals 2x plus 3, y equals 2x plus 3. So there's my first line, and what I'm going to do is put in the second one. This has a negative reciprocal. I'm going to hit tab to put another equation in, and I'm going to put in a fraction, so I need to push Control Divide to pull up my little fraction template, and I want to enter negative 1 on top, on the bottom 2, and then arrow out, put x, and I'm going to say plus 3 again. Those are negative reciprocals. When you turn it this way, those are right angles on all sides, okay? So that's what happens there. Okay, so with that little review, let's go ahead and do the odd numbered problems. 1, 3, 5, and 7. Number 1 says, find the equation of a line parallel to y equals 4x plus 5. But they also want it to have a y-intercept of 7. When I'm talking about y equals mx plus b, the b is the y-intercept. So that's what they're talking about, the b. So they're giving you the b number. They want the b to be 7. And since they're parallel lines have the same slope. So here it is. It's going to be y equals 4x plus 7. Same slope, different b. Okay, number 3. Find the equation of a line parallel to x minus 2y equals negative 10 and passing through the point 0, negative 4. Now this is interesting. When you remember what that point is, the significance of having an x value of 0, they're basically giving you the y-intercept because I don't go left or right, I stay at 0, then I go down 4. That's where I am on the y-axis. So Like once again, they're giving me the b number. b is -4. Okay? So I have half my answer already. However, I don't have my slope because I'm not in slope-intercept form. So I need to get this in slope-intercept form. Okay, I'm going to show you how to put this in this way, but I'm also going to remind you how to put this in the calculator as is and turn on your grid so you could find it that way if needed. Okay, let me zoom in so I can show you my math steps. All right, I put a box around my y term. Remember, I want to get y by itself, so that is my term that has y. I'm going to ignore that for now and move everything else that's on the left side. So that x becomes -x on both sides. Cancel, and these are not like terms, so I don't put them together. I just write them side by side. -x minus 10. So on the left I have -2y. On the right I have -x minus 10. Now what is the number with the x? It's a little invisible 1, and that's really important to remember because you're going to need that 1 in just a second. Okay, the way I get rid of that -2 that's being multiplied to y is I do opposite math, which is divide by -2. That cancels. Now take a look here. I have y equals, and here is my slope. It's -1 divided by -2. Negative divided by negative is a positive. So it's going to end up being y equals positive 1/2 x, and then -10 divided by -2 is plus 5. Now I don't need that b value. All I care, because they gave me the b value of my answer. All I care about is the slope. It's positive 1/2. So my line that's parallel to this line is y equals 1/2 x plus 5. Now that was a whole lot of work. What if you're really you're on a test and you can't afford to get it wrong? Well, here's what you can do to make sure you got it right. You can put in your answer choice. So you can put in the original equation as is. Okay. So I'm going to go ahead and I'm going to put in x minus 2y equals -10. How do I do that? I go to my graph screen, and if I go menu and I hit 3 for graph entry, and I want to put in a relation, that'll let me put this problem in as is. X minus 2y equals -10. X minus 2y equals negative sign with 10. That gives me that line. So here's one option. You could type in what you got as your answer when you converted that. It should be the exact same line. So I'm going to hit tab, and now I'm going to put y equals positive 1/2. So I do control divide, put in 1/2, and then arrow out, put x plus 5. Look, it went over the exact same line again. You see that? Okay, so that's one thing you could do. Now, to make sure that it is parallel, that it's really parallel, this is the one that they gave us, and this is the answer we got. Let's put that one in to make sure it's parallel. Because what we did just now is we made sure the equation that we made is the same one we started with, just converted to slope-intercept form. So now I'm going to put in my answer, y equals 1/2 x minus 4, to make sure it's really parallel. So y equals, and then control divide, 1/2, arrow out, put the x, and then do plus, minus 4. There's my parallel line. They never touch. Okay? So that's a good way to check your work and make sure you get it right. Let's move on to number 5. Number 5, on the directions it says use the graph at the right to answer the following questions. Okay, here's my graph at the right, and they're asking what is the slope of line AB? Okay, well let's find line AB. Here it is. To find slope, you find out either if it's a positive line, you find out how much it's going up and then to the right. But this is a negative slope. It's going downhill. So I need to find out how much it's going down and to the right. So to go from A to B, I'm going to zoom in. I'm going down 1 and 2 to the right. And then down 1 and 2 to the right. And then down 1 and 2 to the right again. So it's down 1, 2 to the right. That is negative 1 over 2. I know it's negative because it's going downhill, not uphill. All right? Number 7, which line is parallel to line AB? Okay, so we're back to line AB. Of the 3 lines that are remaining, there's this one, and there's this one. Now these are both perpendicular, right? They're crossing the line and making right angles. The only one that's parallel is this line, and that is called line, looks like you could call it CD, or you could call it DC, but we usually go in alphabetical order. Not always. So whichever way, if you name it DC or CD, it would be that answer. You could say CD, either one of those. So those are the odd numbered questions for 3-6 parallel and perpendicular lines.